So, very good evening, everyone. Myself, Dr. Ajay Kumar. I am Executive Director of SARA Institute of Data Science, and I welcome to all of you today to the second day guest lecture by. Today we are going to have Dr. Cecilia from Germany, and she is a by training in life sciences, and right now she is doing postdoctorate in Germany in Max Planck Institute of Life Sciences. And she is expert of illustrations and our language. And she's also our language enthusiast like me. And we both believe that data science education should reach to each and everyone, irrespective of all the barriers. And that's why I humbly requested to Dr. Cecilia to take a session for SARA students in this summer school. And it's our honor and pleasure that she humbly accepted this despite her busy, very, very busy schedule. I can understand that. But thank you so much, Dr. Cecilia, for giving time to us. And we are very excited to learn from your session about the data wrangling. And now it's over.
Super. Thank you very, very much. I'm very happy to be here. I totally agree with everything you said, and I think R is the best language for it because it's so open and open source, and everything is so well documented, and you can find everything you need online. I will share in the chat just now. Everything I'm showing you today is in this GitHub repository, including the slides. Actually, the slides, I can also send you the link. So you can, here you go. This is the link of the slides, so you can follow along with me. And don't worry if you never downloaded data from GitHub, we will do it together. I just have one question I think I forgot to ask. Do you all guys have R studios? Because I think this was not the first R related session,
Yes,
right?
yes, they
Good.
all have ours.
Perfect. Perfect. Then we are set. Everything else we will do together. I have a tiny presentation and then we will download the R script and then we will open it together. I will share my screen so you can follow along with me. And at any time, please stop me if you have any question, if you're lost, if you need anything, please stop me, ask question. If you don't feel like unmuting yourself, you can write in the chat. I'm here to answer all your questions today. Super. Okay, so let's start. So today I'm talking about data wrangling with the tidyverse. I am really super happy to have you all here. Yes, please turn on your camera if you want. You are very tiny on my screen, so I can't see you super well, but please, I hope it's gonna be a very welcoming space for you all. And in this session, you will learn how to clean the data, how to visualize it, how to transform it, and explore it to get the most out of it. So about me, I'm a postdoc. I work in Germany. I work a lot with behavior in animals and cognition. But I really love to teach and to mentor students, so I'm very happy to be here today. And I do workshops on Quarto, on personal knowledge management, open science, R, and on students of any level. And if you are curious about my work or if you want to connect after the workshop or ask me questions, here are all my handles. Please feel free to connect with me. So, what do we mean when we say data wrangling? So data wrangling refers to all the steps we take to prepare the data that we get from either ourselves or other researchers for analysis. And usually, this I want to say, the data wrangling part takes 90% of the whole analysis. So you will see, like when you do statistics or All of that, if your data is messy, it's really gonna take forever. But if you take your time and do this part well, then everything else will go very easy. So there are different steps that you can take, and data wrangling includes cleaning messy entries or filtering or transforming the data. For example, you have some columns that you want to rename, or filtering rows that you don't need, or creating even new variables based on the one you already have. And also summarizing and creating new tables. So what is the tidyverse? The tidyverse is not one package, but it's a collection of different packages. And it's specially designed for data science. And these packages work really well together, one with the other, because they follow a unified grammar. And we will see this together later. So some core packages we will see are dplyr, and this is to manipulate the data. ggplot, maybe you heard it again, maybe you used it before, is to visualize the data. Then readr is to import the data, and tidyr to tidying it or reshape it. So we will not probably see all of these packages, every single package today, but you'll get a feel for how they all work because they are all very similar. And as I said before, they have a unified grammar, so they can work together pretty well. So why everybody, or not everybody, but most data scientists use the tidyverse packages? It's because sometimes you have some functions that are very hard to understand what they do. But in the tidyverse, it's really easy because you have a function called filter that you're like, yes, it will filter the data, or another one called select, which will select the rows. So it's a very readable syntax instead of these scripted commands. And you can get these consistent verbs to just do the job. Then the other thing is that you can chain multiple steps together with this command that it's called pipe. You can think about the pipe as, like I always tell my students, when you use the pipe, you can think in your mind that you tell yourself and then. So you write a code and then you put the pipe and say, okay, you do this function and then you do another function and so you concatenate multiple functions. Don't worry if it seems too much because we will see this together in the hands-on section. And yeah, the other great thing about this is that it's so well used by so many data scientists that it's very well documented. So nowadays, I use it every day. Sometimes I forget the name of a function. I don't remember how it works. I don't remember the syntax, and I'm really just a Google search away from having the answer. So there's a lot of community support and a lot of documentation. So if you have used RBase before, I think, because yeah, I have started with RBase 10 years ago. And when I moved to the tidyverse, I found it very intuitive. And I think you will find it too more intuitive and enjoyable. So, this maybe I will fix. So today we will use the dataset called Gapminder, which has data information about countries and years and different variables like life expectancy, GPT per capita, population, and it's a very clean and well-structured data set, and it's perfect for practice. And usually I use different kind of data set more for biologists, but I think this will be probably more interesting for you guys. So before diving too much into wrangling, we need to talk about tidy data. Tidy data is a principle. We need to understand what it is, because also a lot of other packages that are not within the tidyverse use this, they ask, let's say, this tidy data structures. So we need to understand what that means. And also because all the tidyverse functions assume that the data is organized in a certain way, otherwise that would not work properly. So in tidy data, each variable gets a column and each observation gets a row. And each type of observation is in a separate table. That is it. That's the only thing you need to know. And actually, you don't even need to remember that much, because you will see it, and the more you practice with the tidyverse, the more you will feel this is natural. It's just something maybe for today to keep in mind. So what we will do today and what you will learn, we will explore the dataset with some basic function like glimpse, summary. We will filter and select some rows or some columns from the dataset. We will transform some observations, and we summarize them. So these are the previous, like it's called exploratory data analysis. You might have heard of it as ADA. So we need to understand how this data set is organized to then do some, maybe in the future, some statistics or some draw some conclusions. And then we can also try to visualize it at the end. So you need RStudio, we have it. You will need this package installed, but this is the first thing we will do. So if you don't have it installed, don't worry, we will take our time to do that. You need the R script, this we will also do together. And then in the GitHub repo that I shared in the chat, there's also a file called, with this extension. This is a markdown file. We will have a look at it at the end of the workshop. This contains the post workshop notes. It's like we have all these exercises and they are compiled and they have the answer to the question. So if you miss something today, you can have this document that has all the answers and all the exercise done. So don't worry if it's too much and if you lose something today, you can practice it. Yeah. Okay, so if everybody is ready, I will open the R script. We go through the GitHub repo and we see how to download it. Maybe here I really need you guys to tell me if you're following, if you have the R script, we will do it slowly and then we will walk through the R script. And again, ask question anytime you need and if you get lost or anything. Okay? So I have my R script open here, but let's see how to do it. So once again, I will copy this in the chat. Let me see. Here you go. So you should have this link to go in this repository online. Maybe if you can give me a thumbs up when you are in the link, so I go forward with the next step. I also wanted to, no. Here. Now I see you all. Okay. Is everybody in the link, in the GitHub link? Yes, I see one thumbs up. Also in the chat. I can zoom it. Yes, of course. Let's see. Yes, 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 perfect. If somebody is lost, please tell me. We go very slow today. So there is a big green button here. You can click here on the side where the arrow is, and you can download it. So I assume maybe some of you have already worked with Git and GitHub. If you do know how to clone the repository, please go ahead, but today we won't go down that path. So we just download it like normal files. And then this is my very messy download file. You can put it everywhere you want. You can also leave it in the download folder, doesn't matter. And you will need to extract the zip file. So for example, I do it here, extract here, and I have this folder, data wrangling tidyverse. When you are at this step, please let me know. If you get lost, let me know. The goal is to have the folder in your local computer. So once again, we click the green button, download, and then it should be in the download folder. Hardik is done, perfect. Are there questions? Is there anybody lost or maybe takes longer? Sometimes the connection is not great, maybe. Hardik, if you are done already, you can open the folder and you can open this. No, well, you can do it also from RStudio, but if you double click to this R project file, then the repository should open in RStudio. What about the others? Is everything working or is there some? I can also send you the script in the chat, but I think this is a good practice in general because you can find sometimes some nice repository in GitHub that you want to practice with, and you can just do it because everything is free and open. Just in case if somebody is having problems, I sent the script in the chat in Zoom. There are two files. One is .r, so that's the script we need, and the R project. That's not necessary, but maybe we can spend a word or two on talking about why an R project is always better. So let me see. Let's close this for a moment. Yes.
Dr. Cecilia, I think
Yes.
students are able to download it,
Yes.
but they are not, somehow it is not coming up. Some of are not able to, get it properly. So I guess we can continue with
Okay.
the demo. So at least they can see the demo.
Absolutely. And also, like, if you guys want to try, I sent the R script in the chat. So
Yes,
you can also try to download it in the chat.
yes, yes.
And I I suggest, so I sent two files. I suggest that these are the two files I sent.
Okay.
I suggest that you download both
Okay.
and put them in a folder. Like anybody can create a example folder, a fake folder. I will just do it now in my computer.
Okay.
So this is my computer. It's very messy. I have a lot of
So
weird folder.
we need only two files, the project file and the
Yes,
R script file, right?
exactly.
Okay. So let me
For
help.
following up, yes,
Yes.
exactly. Yes,
Yes.
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 You please
Give
help the students. So
so
yeah,
give me 1 or 2 minutes more. I will just help the participants.
absolutely.
We'll continue.
Absolutely. Yes, for today, yes. And then the rest is like this post workshop if they want to have a look. It's on GitHub. I just put the 3 steps you should do with these files that I put in the chat. You create a folder first. You can also try to do it myself. Workshop. Then I download the files from the folder. Zoom asked me, where do you want to put them? I want to put them in the folder I just created and save. The name, yeah, Lata, Wrangling.
Now all participants are ready now, and I think we can start the demo. Thank you.
Perfect.
Yeah, thank you for
So
waiting for us. Yes.
no problem, absolutely. That's why we're here today. We have to learn all the things. So we should be all in this screen, let's say. Don't worry if this looks different than yours. That's completely normal. And even if you didn't manage to have the ALF script, you can look with me or with your friends, and we will go very slowly.
Dr.
So,
Cecilia,
yes,
one suggestion. If it will be helpful, if we can zoom little bit your R Studio
of course,
script file, if you can
absolutely.
zoom. Yes.
Yes,
I
yes,
think
you're
Control
right.
plus will be helpful. Control plus also.
That's true. Yeah, yeah. But
Yes.
also now it should be a bit better, or?
Yes, much better.
Mm-hmm.
Thank you.
No, absolutely. Let me know exactly whatever you need. So maybe also a bit more. Anyway, it's not like we have super long lines. Let me see. Yes. And also this. Yes. Okay. So we are here. All of us are here now. So if you haven't already, if you have never used the tidyverse, the first thing you have to do is this. So you will go to install packages, tidyverse, and you run this line. So you can run it either with run up here or with Control R. I will write it in the chat to run a code line. Control. So I am here on this line and I run, and it tells me installing packages. It takes a minute or two. So everybody, please just run these first two lines because it will install the packages that we need for the demo. And when it's done, it will tell you done and where the packages are. You don't need to know, it's not important. It's just important to know that it worked. Same for Gapminder because that's our data set. Let me know with thumbs or in the chat when both of our packages, good, I see already a thumbs up, when both of the packages are installed. Yeah, I see another thumbs, perfect. Okay, I will continue, but if we need to stop, please let me know. There's no rush. Okay, so installing the packages is great, but that doesn't mean that R knows that we need it. So now the packages live inside our computer, but we also have to tell R that we want to use those packages now. And to do that, we need to run this command. And this command just says, okay, the tidyverse, just open the library, the package, because we will use all the function inside. So you can also highlight both lines and run, and it will just open, and it tells you a lot of things happening here. And now we know that the packages are loaded. Another way to see if this was successful, you can go here on the right side. You see this packages. If you click on it, well, I have a lot of packages, but you can also search for the one you need, for example, tidyverse. And as you can see here, maybe it's tiny, but here there's a tick. This means that the package is loaded in this R session, so we can use all the functions inside. This is just a check. So we loaded the package, and now we want to load also this data set. So we run this, and we just select from the library Gapminder this data that we will use for the session. Let me know, is everybody here with me? Have you loaded the packages and the data? Let me know if there's some problems or is everything good? Packages loaded, data loaded. You might see from here the console, like everything is run normally, it's not throwing errors. Is everything good? Good. So let's move to the first exercise. If we need to stop, please let me know. But I assume everybody is okay and everything is working fine. Okay. So the first thing we will look at is like, what is this data set? We have no idea. We just loaded the data, but we have no idea what is it. And this is where the first function here comes in handy. The function here says head. head of the data that it's called gapminder. What does this function do? Let's find out. So we are here, line 19, and we run head. And see what happens. It says, okay, this is head of gapminder, right? What this function does is that it gives you a table, like a table, 6 per 6, meaning 6 columns per 6 rows. So the head of this gapminder dataset, it gives you the first 6 lines, so the first 6 rows of this dataset, and the name of the columns here. Okay? So these are questions for you guys. After running the head, how many variables are there? And by variables, I mean columns. How many columns can you see? Type it in the chat or hold it up with a hand. How many columns are there in this dataset? Ah! Tarun is correct. Yeah, Ansel is correct. It's 6. If you don't want to count them because maybe you get lost, like these are 6, maybe you missed pop. Yes, exactly. So it tells you here. It tells you 6 rows and 6 columns. So the head function always gives the first 6, okay? The first 6 rows. Of course, this dataset is not only 6 rows. Of course, also because you can see the first 6 goes alphabetically, right? So it starts with Afghanistan in Asia, and then there will be many more, but we only see the first 6. So I want to know also what types of variables can you identify? What do I mean? Like the columns, these 6 columns, underneath, there is this information. Does anybody know what this information means? If not, it's okay. We can see it together. Can anybody guess? Or no is also a good answer. No idea is also good. Does anybody know? Yes, in a way, yeah. There are different types of data. We are not interested yet what the data is about, but we want to know what these are. So we know that there's, who said, Hardik, exactly. There's 3 different types. There is FCT, this one. There is int, right? And there is dbl, right? There are 3 different types, right? What do they mean? So the first one, FCT, stands for factor. Factor means that it's a category that is not quantifiable. In this case, continent, for example, is a category. We cannot number it, right? It's like saying apples, oranges, these are different categories. Fruit, vegetables, this is different categories. And usually they are labeled with factor. Then we have int, that stands for integer. Integer is just a number that is not decimal. It's a round number. So for example, in this case, it's here. So you see there's no decimal after it, okay? And then, of course, because int is integer, and this means double. That is a number that has decimal. So as you can see, it's both here, but also here. Okay? Is all clear until now? Are there questions? So by the question, what types of variable can you identify? We can identify factors, integers, okay? Wait, I want to close this because it's confusing and this is confusing. Oops, sorry. I need to move you guys away. Ah, here we are. Everything clear so far? So here I have to, yeah. Can we move to the second function? Good. So as I said, head is great. You can find out which are the columns, which are the types of data, and you can have a glimpse of the first few rows. But actually it doesn't tell us much about the data set, like how many rows are in this data set, how much data is in this data set. So for this, we can use glimpse, which you can use to inspect the structure of the data. So we are at line 26 and we run this glimpse and see what happens. So this is already a bit better, right? Because for example, an information we didn't have before was this, right? So this tells us that the rows in this dataset are 1,700. It's quite a lot. So there's quite a lot of data in here. Okay? So I have, oops, sorry. I have another question. Well, this we kind of answered before. What are the variable types? We just saw that, factor, integer, double. And can you tell me which variables are numeric and which categorical? So let's put it this way. Which variables in this data set are categorical? And we said like categorical, like as we said, apples and oranges, like something you cannot count. Which one are they? Write it in the chat. Oops. Which variables in this data set are categorical? Or we can call it also factors. There's only two of them. Which one are they? Trick questions. Which variables have no numbers in it also? You could. Yes, year, life expectancy is numerical. Also population is numerical. Categorical, country and continent. Exactly, perfect. So we can see it both by the fact that it says here factor, but also if you see the data itself, there's no numbers. That's good. Perfect. If everything is clear, we can move to the summary. Summary is a great function because it actually gives us already some statistical values, which is not that bad. So if you're ready, you can try to run line 33 and see what happens. I will run it as well. And I will make it bigger. Wait again. Here we go. So you can see it at a glimpse. So we run summary of this dataset gapminder. What do we see? We see that for each column, it gives us some information. right? For each column that we have, for example, country, it gives us some information. So, for example, let's take one numerical value. For example, year. Okay? In year, it tells us which is the minimum value. So min stands for minimum value in this column. And here we can see the value is 1952. That's the earliest we have in this dataset. What is the median? What is the mean? In this case, is the same. It's 1980. And what is the maximum? 2007. So this dataset goes from 1952 to 2007. This is already a great information to have. What about population? So in this case, here it's the number of zero, right? Do you guys know? I think you know better than me, like this count of how to put like not the decimal, the zeros after the number. So minimum value is 6 point, wait, plus 4 zeros. I have no idea. Don't ask me. Well, it's a number. So what I wanted to show you here is that different values, variable types, have a different summary. So as you can see, here has the minimum value, first quantile, median mean, third quantile, and the maximum value. But that's not what you see, for example, in continent. In continent, because it's a categorical value, you cannot have minimum and maximum values there because you just have a factor, right? So what it says instead is that 620 rows or observation are labeled Africa. Is this clear? So for example, Africa 624 means that 624 observations are, let's say, labeled Africa. Same for Oceania. Oceania, it's only 24. So this is already another kind of interesting information you can have just by looking at the summary. So, okay, which one has the most observation? It's Africa. And which has the least? Oceania. And Americas, Asia, and Europe are more or less the same observations. Okay? So, for example, in here I can ask you these two questions. The first is, what's the range of life expectancy? What does that mean? The range is between minimum and maximum. What is the range based on the summary? So you have to go to the column life expectancy, this life exp, and you have to have a look at the minimum value. It's 23 years and a half, and the maximum value is 82 year and a half-ish. Yes, the range is exactly that. Perfect. Nice. Perfect. Ah, you guys are the best. What about what's the median of GDP per capita? That's easy. There's just one line to look at. And the column is called GDP per cap. It's the last column. What's the median? Perfect. Yes, that's it. So with three functions, 3 lines of code, we already realized so many things. Like I just gave you a data set that maybe you never saw before, and you already have a lot of information about it with just 3 functions. So this is already a lot that you can investigate from just very basic functions. So every time you get a new data set, that's what I do as well. Sometimes people send me data, I have no idea what they are about. You just run these 3 functions and you have kind of an idea of, okay, I have this many rows, I have this many columns, this is the range, and everything is a bit clearer. Okay? Now we start with the pipe. The pipe is my favorite thing in R and the tidyverse. So you write it like this, but there is a trick. So in R, you can type it faster by doing Control M. So try it yourself if you write Control Shift M. Sorry, not Control M. I need to delete this. It's Control plus Shift. Try it yourself. If you do Control Shift M, the pipe appears. It's very handy. So this is called the pipe. You can think of it by saying and then. This is a trick I have. Somebody, when I started using the tidyverse, told me this, and I never stopped thinking. And then, because it's easy to remember what it does if you keep thinking like, and then. Because what we are doing now is just doing that. We take the data set, Gapminder, and then we use this function called distinct, and then we tell it what. And in this case, we take a column, for example, continent, and we want to know what are the distinct values of this categorical value. Okay? So if we run this at line 40, what does it say? It shows us the different entries in this data set that are in continent. So now we know that in the continent column, there are only 5 different continents. Okay, these are the only different continents. Exactly, 5 continents. What is missing? Antarctica. Nobody lives in Antarctica, so perfect. We don't need it. Right? So this is great information. If we wouldn't have had this before, or yeah, it's like, but what does that mean? Because before we had, for example, when we use glimpse, it doesn't tell us how many continents are they, right? It just lists them alphabetically, and if it's repeated all the time, Asia, 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 Europe, then you cannot see which one are they. So if you use distinct, you can see them faster. The same we can do for year, for example. So if we run the same line, but we change the column name, so we do run line 41, what can we see? How many distinct years are there in this data set? You can see it from here or from here. Exactly. 12 different years. And you can also see from this code that actually they are not every year, right? Because, for example, we have 1952, and then 1957. So there's a gap between the years, right? Okay. So this we kind of answered. How many continents? 5. Which years are represented? We have them all, and they are 12. Now I want you to try, because here, as you can see, we just put the columns names, right? So what other columns can we put? For example, what if I write Gapminder and then this? By the way, if you start typing it in our studio, is great because it tells you which one do you want, this distinct. And then I say life expectancy. What happens? Do you see what happens? What's different if I put life expectancy, for example, which is a numerical variable? What happens is that there's not many distinct values. They're all different numbers. So it just gives them all of them. So maybe for numbers, distinct is not the best option. Like you might want it, for example, for continents or for country, when you have a factor variable and you want to just know, okay, how many different continents I have. I don't need to know how many rows are there, but I want to know how many continents are there. Or how many, for example, which one was the other factor variable in our data set? We can look at it again. Head of Gapminder. Which one was the other factor? Factor or categorical variable. What can we put here? We put continent, but we can also put country. Right? That was the other factor variable. These were the two, country and continent were the two factors, so categorical variables, right? So what if we run this Gapminder distinct country? What can we see? Now I want to know, I ask the question in the chat. How many countries are in this data set? 142. Yay! Perfect. Where did you see it? Here, because this is the number of rows, or, well, you can sum it up, because here it says these are the first 10, but there's 132 more. So 132 plus 10, 142. Super. So because you guys asked, we can also try to do distinct GPT. Right? How is it written again? GDP. GDP. Yes. What will happen here? Let's see. No idea. So in this case, I put again a double, so a number with the decimal. And what happens is that it gives me back all the rows. So this, if you remember, this were our data set has 1700 rows. So this means that in GDP per capita, every row has a different number, right? So this is also good information to know. I don't know if we need it, but just so you know what happens if you put a number with the decimal, okay? Are you all with me? You need a break? You need ish? Come on, I see a bit, maybe. If you have question, please stop me. If it's too fast, stop me. But remember that you have Maybe this is a good time to show you this file that I will send in the chat as well. Let me do it now. So your brain can breathe a minute, and I send you this file, post-workshop notes. Yes, I will continue immediately. I will send you this file so you have. Super. So you have this file now that has all the exercises with it, plus the answers. What are the answers? Eh? It will have the answers. I thought I did it already. Maybe, well, the one in GitHub, I'm sure it was uploaded. Was it uploaded? Well, it doesn't, but I will put the answers as well today. So you can have it tonight or tomorrow. It will be there with all the sessions and all the answers and everything done, so you can follow through if today was a bit too much. Okay, we are here. We answered this question, we're super good, and we can try a different function now. So now we want to know, because when we run this distinct continent, we know that there are 5 continents, right? But we don't know how many observations are per continent. So what can we do here? We can use the function count. Count just counts the number of rows associated with one specific factor. So if we run this, what happens is that it tells me, well, we wanted to know by continent, so it lists the continents here, and it tells us how many observations are there. You might think this is familiar because we did it before. When we ran the summary, that's exactly what we had here, right? This is exactly the same as this. So that's why summary is also a great function. But yes, this is how you look at each observation, how many observations are per factor. And in this case, we used count. In this case, we used the summary. Same thing, 2 different functions, okay? So, you know already the answer because we saw before, but let's see, which continent has the most country? In this case, it's great because it's also both alphabetical and the highest number is up, but don't get fooled sometimes because this is alphabetically ordered, right? So it won't be always like this, that the highest number is up. So continent that has the most country is Africa, according to this data set. Huh? The second highest is Asia. Yeah, the second highest is Asia, followed by Europe, followed by America. And the least, the continent which has the fewest countries is Oceania. Yeah. Good. We are good. We are golden, and we can go to exercise 2. Select and filtering. This is the best. This is my favorite thing to do. So, when this is not the case, but sometimes you will have data sets that are full of columns. They have so many columns, and you don't really care about all of those columns, right? For example, we can say, okay, in this data set, since I'm super bad with numbers, I don't want to have the population column. It's just there, but I don't want to use it for my analysis. It's just taking up space. I don't want it. But I also don't want to modify my original dataset called Gapminder, because maybe in the future I will need this column, but for now I want to remove it. So what do? I create a new variable called Gapminder selected. Or you can call it however you want. We can also call it Gapminder 1 or without population or something. Selected, for example. And then we tell him that this new variable will have Gapminder, our dataset, and then we want to select some columns. So the columns that I want in the new dataset are country, continent, year, life expectancy, not population, but GDP per capita. Okay? So I will run this now. As you can see here, I have my new dataset that has exactly the same number of rows. That didn't change. But it has one variable less, so one column less, which is pop. Okay? Is everything clear for now? We can do it again with, for example, now we want to remove life expectancy. And I will copy this because I want to create a Gapminder selected 2, for example. And if I run this, I have 3 datasets now. And I have one variable less, so one column less here. Okay? So you can play with it and you can try it yourself, but for now, we want to see the first few rows of Gapminder selected. Ha! Perfect! We can also do head of Gapminder, right? And we can see the difference between the two. Gapminder selected doesn't have population, and Gapminder has population. Super. So did selecting the columns change the number of rows? It didn't, right? So we removed one column or two, but the number of observations or rows remained the same. It's always 1704, right? Of course, because we're working horizontally, so on the column, but not on the rows in this case, okay? And why we might choose to select specific columns. As I said, sometimes you have some data sets that are just very complicated or very full of columns that you don't really need, and you want just a selection of the ones 4 or 5 that you want to work with, and so you want to just make it easier, okay? This I actually, oh yes. Okay, so next. Now, let's try something a teeny bit more complicated. Now we want to filter some data. For example, I'm from Europe, so I chose Europe, but we can also try with another continent later. So I want to know so I create a new variable here. Because again, I don't want to mess up with my original data set too much. So it's good practice all the time to create a new data set for things you want to investigate. And I called it Gapminder Europe recent because it's like the last millennium. So I take Gapminder selected, the one without population, and then I filter by the continent that is equal to Europe. So what this does is just out of all the continents there, you choose the one that is called Europe. And then I want everything that is bigger than 2000 in the column year. Okay? And then I want to arrange all those rows, not alphabetically anymore, because I don't need the alphabetical entries. I need them to be descendant. So not ascendant, but descendant, based on life expectancy. Okay, it might look like a lot, but we will now run this code and see what happens, okay? So we filter all the rows that are labeled Europe in the continent and that are older than 2000, the year 2000, right? Because here is a year bigger than 2000. So let's run this whole block. You see, it went through, but we see nothing. So here we can either open it here, but now we know how to do it with head. So we run head of Gapminder Euro recent. What do we see? We see that the year is, everything is bigger than 2000. The continent is only Europe. And it arranged the life expectancy column from the biggest to the smallest. So we see that the biggest number here is 81.8. Okay? Is everybody with me? This was a bit more complicated than usual. Are there questions about this? Because might be a bit. So based on this head, I want to know which country has the highest life expectancy. Based on this. Oh, error. Okay, you have an error because it doesn't find continent. I see. Error in filter. Did you run the whole block? So this whole thing. Not just this. Because I think if I run this, yeah, no, apart that if I run this, it doesn't work. Anyway, so you run the whole block, right? Okay. And did you create this Gapminder selected? Did you run this? You can also try without the selected. Do it with Gapminder like this. And see if this works. No? Oops. Ah, can you tell me what was the issue? Did you... Because it's good to know when errors are solved. Ah, okay, yeah. That's okay. You could also run it with Gapminder normal. I think the answer would be the same. So yeah, this is the one with Gapminder, not Gapminder selected. We have the population. It doesn't matter. But so my question remains, which country has the highest life expectancy? from this output? What can you say? Does anybody else has some errors or issues? Are you all with me? Let me know. Iceland, yes. Is everybody on top of things? So if you want, if you already ran this, everything was fine, you can try to play with changing the names here. So if you remember which continents we had, yeah, good. You can try to change Europe into Asia. What will happen then? Or with Africa. Try to play around with it. Also, you can change the year. So I can say year bigger than 1980. Okay? Try to play with it. Maybe we can all look at Asia of year 2000 and more. What do we see there? We see that the best is Japan. In 2007, had life expectancy of 82.6. Okay? So yeah, play with it. This is a great data set to just investigate what's going on. Okay? I will wait a couple of minutes and then so you can play with it. Try to change you can also actually, if you want, change instead of continent, saying country. Oops. And then, of course, you cannot say Asia anymore, but I could say, for example, Italy. I'm from Italy. Let's see. What does it say? Mm-hmm. Or Switzerland. Good. Not Gapminder selected. Did you all run the Gapminder selected? Because probably one problem would be that you guys didn't run this line, but that's not a big issue. If you want to use the Gapminder, please use the Gapminder. There's absolutely no problem. We can also all keep going with the Gapminder. But yeah, this is just an example. Play with it and see how you can see the different entries, okay? So if we are back to continent Europe year 2000 in Gapminder, it doesn't change anything. It just shows the population population column, okay? So if that didn't run, it's because this was not run. But again, no issue. So if the head of Gapminder is working, that's completely fine. Okay? Okay. I will move forward, but again, if you need some time, we can also take some time at the end. We will go to exercise 3 now. And now we will create a new column. Okay? So we will use Gapminder, so no need to have the different data sets that we created. Okay? But we still want to create a new data set called, for example, Gapminder GDP. And our goal is that we want to see the total GDP. So it's the GDP per capita multiplied by population. And this we want to have in a new column. Okay? So how to do that? Please R, create a new data set called Gapminder GDP. We will take Gapminder dataset and then we will mutate, and this will be, the new column name. This will be the new column name. That will be GDP per cap, which is the column that we already have, multiplied by pop. Okay? So this will create a new column with this operation in it. And the new column will be called GDP total. Okay, let's try to run it. So let's be here at line 85 and we run. What happened? Let's see. Through head. Look what happened. There is a new column. So the function mutate just created a new column called GDP total that has the GDP per cap multiplied by this number. And this is the result. Okay? Is this clear? Not really? Is the new column kind of situation that it's not clear? It's all good? I don't know. Give me thumbs or chat with me. So the function mutate, in this case, created a new column called like this, equal GDP per capita per pop, which were both columns that were already there in the data set. Okay? Super. But actually, I don't know about you guys, but I don't really like this name. Like it's a bit confusing for me because it's all cramped together. So I want to change this name of this column. So to do that, I tell it. I say, okay, we create this new data set called Gapminder renamed. Again, you don't have to create all of these data sets. It's just for as an example, so you can follow through. But what we do now is that we take this one that we just created, so you have to run this line. We take this and then we rename this column, this column that is the one we have now. But before we tell R the new name. So first you have the new name you want to rename it to, and then equal the name, the old name. Okay? So we take the data set we want and then rename, new name. So this is the rename. Rename. It goes new column name. equal old column name. Okay? This is the structure of this function. So we say rename. This is how I want the new column to be called. But the column is this, that it's already existing. Okay? So what happens if we run this? We run, we do the head, and look. This is how it was before we run the change. It was GDP per cup. And now the new name is this. Nothing else has changed. The values are all the same. Is this clear? We can try with maybe an easier example. Oh, where are you stuck? Can you tell me the line of the R script? You can see them on the side here. Renaming. Okay, so this you're not able to run this one. It's not running. Does it give you an error? Could it be that you didn't run this one here? Can you run the line at 84 first? Try to run again 84 and then 94. No? So does the one at 84 run right without any problem? Because we could also have, instead of this, try it like this. Try the rename function. I copy it in the chat. 84 not running. The 84. Can you, if you have an error message, can you paste it in the chat? So we can have a look. 84 is not. So does it give you an error message or is there something weird happening? Because this should run easily because we are using gapminder. Not so, yeah. Be sure that you're using gapminder, that all the variable names are correct. I will paste this again in the chat. Maybe something has happened. Have a look. And tell me, paste in the chat the error message if there is one. So we can might need to fix. So this is the output. So there's no error message, right? Renamed. So if you run this, if you run the head, does it, sorry, not this. Sorry. This is my, so this is the renamed, wait, I delete this. So the Gatman renamed run, did it give you any any error messages? one way to check if this exists is either you can look at the environment here on the right, or you can just copy. Like, let's see if gapminder renamed exists. And it tells you, yes, it's all of this is there. Okay? If you guys are stuck somewhere, please either tell me the line where you are at, or paste the error message, or just tell me so I know how to help you. Okay? Is somebody still stuck that some lines don't run? Is not working. Ah, that's weird. So you run because sometimes if you run the code, so have a look here. You just run it like this, and this is also my output. This is right. This is okay. And then it just gives me the next line to say, okay, what next? This means it has worked. So is this what perfect. He's sending a picture. Let me see. Oops. Rename. Eh? So you are environment. Where is your console? Yeah, you are. Everything is fine from my. So can you try to run this just to see if it has worked? Because I see here it just ran. I don't know what's going on in the environment. So can you try to run gapminder renamed only? And does it say that it doesn't exist? Or does it say that, does it show you this? Oh, okay, super. Good. So it's not important if it doesn't run, if it doesn't give error messages. I just want you to learn, like the important thing is how this function works, okay? So I wrote it also here, rename once the new column name and then the old column name. So we can make another example. We want gapminder renamed to be gapminder renamed. So we take the same data set and then we rename the new column name. I want, for example, population to be not pop, but population. And the old column name is pop. Okay? This is another example. It's exactly the same thing. Okay, and if I run this, and then I see the head, I see that it's not pop anymore, but it's population. Another example. So this is the only thing to remember from rename. First the new column name and then the old column name. Okay. So now I want you to learn before we might want to stop. Let's see. Another great example of how mutate can create new columns. Okay. So in line 107, okay, we can also use Gapminder. So if you did a run Gapminder renamed, you can also use Gapminder, okay? Use whichever you want. So here we want to take Gapminder or Gapminder renamed, and then we use the function mutate to create a new column called life category. You can call it however you want. This is gonna be the name of the column. And then we use this function to say when life expectancy is smaller than 50, you will call it low. If then comma, you go, and then you say flex expectancy is more or equal to 50 and but smaller than 70, so it's within this range, equal or bigger than 50 but smaller than 70, you call it medium. And if life expectancy is more or equal to 70, you will call it high. Don't worry if it looks a bit too much. We want to see what happens. What happens if we run this line? I will do it on my computer. You can follow along. If you have Gapminder renamed, do it with Gapminder renamed, but you can also do it with Gapminder. This because you will all have it. So let's try to run it. What happened here? We have a new life category column. Okay. We have it here. At the end, it created a new column called life category. Here, I told him mutate life category. Okay. And then we have different categories, which are low, medium, and high. We can also, if you want, open it here. Not this. Where is it? The Gapminder categorized. So we have life category low, medium, and high. Right? And it shows how to connect them because I told him here. So when life expectancy is smaller than 50, you will write in the row, you will write low. I could have also say you write low like this, or yeah, this is what he will put inside that cell when he sees that life expectancy is lower than 50. In this case, it's 20. Here maybe it's a bit tiny. It's 28 or 30 or 40, it's all low. But then when you go up here, it's 59 or 64, then it's medium. And if it goes higher than 70, then it's high. It's all clear here. This is a bit more complicated example, but it's good to have, and you will have it in the R script, so you can have a look at it also after the workshop. And you can also try to change variables and create your new columns based on whatever you want. Okay? I know it looks like a lot, I know, but it's good practice. And it's also, for now, maybe you are a bit overwhelmed but you have it for tomorrow if you want to have a look at it again. Maybe these things need to sediment a bit, okay? So maybe if there's time, I don't know, maybe you guys need to go to the next session, or do you have still some time? Maybe we can have a look at the last
We,
exercise together,
I
or
think, yes, I think students are able to follow Dr. Cecilia,
yes,
and it's going awesome. Students were able to perform with you.
nice,
And
that's great.
and I guess we can go like if you can explain the codes below this one, you know, the examples below
Yes,
it, then
of
they will
course.
try on their own. They will try on their own.
Perfect,
Will be fine.
perfect. Let's do that. Let's do that. Okay, so we want to know now. So I don't know if you remember from my presentation. I was very happy about the pipe. Maybe you can have a look at it another day. But the pipe, I said something like you can stack different functions together. And that's why the pipe is so good, because you can put different things, right? We saw it kind of before, but you can put different things one on top of each other and say, I want you to do this first thing, which is filter, for example. Then we want to do, and then we want to do a group, and then we want to do a summary. So this is great. You can put as many as you want with the pipe. So this is just as a reminder for you to know in the future, all of these functions can be stuck one on top of each other. In this case, what I want to do, I want to calculate the average life expectancy per continent only for the year 2007. So how would I do that? So first of all, I have to filter only the year that is equal to 2007. If I run only this, what will happen is that it will give me everything in this data set only for year 2007, okay? If I say a different year, I don't even know if this is there, but let's see. No, there's no 80, maybe it's 82. If I put another year, it will give me everything in the data set regarding year 1982, okay? So we want to filter only the year, for example, 2007. You can choose the one you prefer. Then I want this new data set to be grouped by continent. What does that mean? It means that it will take the column continent and it will group all the entry together that belong to the same continent. Okay? So for example, here you have two lines called Africa. This will just put them together. So all the lines that are with the same continent will be put together. And then pipe all the time. And then we want to summarize and have the mean of the life expectancy of that continent in a new column. And this, you might remember it from here, is the same structure. Summarize is similar to rename. We have a new column name, which in this case is mean life expectancy. Then we have some calculations. For example, in this case is mean, and then the old column name. This is exactly how this whole thing works. So if we run this, I know it might seem like a lot, but it's good to have it, and then you can practice yourself when you have time, okay? So now I run this code, very complicated, and I want to see what's the output. So as you can see, I don't have countries anymore. I don't have population. I don't have all of those columns. And this is because I used this line. So I wanted to group all of my entries by continent. So this is what it did. It just gives me the continent. And then it tells me this is the mean of life expectancy, which I calculated here, and I put it in a new column name called mean life expectancy. Okay, so based on this, which continent has the highest average life expectancy only near 2007? And again, they are alphabetical, so it's not Africa. It's not the first one. You have to check the numbers. Yes. Super. And now I want to make your life complicated. I want to know, let me check the data set. Yes. Look at the chat. I want to know which country, not continent, had the highest average life expectancy in 1987. So I want you to go in this dataset and change two things. And then I want somebody to paste in the chat the changed code. The first that can run it will paste it, and then we will run it together. Or give me the answer. Either or. Which country, not continent? And the year is 1987, not 2007. I don't do it yet because I want to see you guys try, and then I will write it in this big screen. So what do I have to change? Oh, this we know, 1987. Super! Yes, and then group by country. Okay, are you all there? So if we run this and we run this, what happens? Which is the country who has the highest average life expectancy? Well, let's say, yeah, among the first 10. Let's not get too complicated. Among this first 10, which one? Which one has the highest value here? It's, yes, Australia. Ding, 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 ding. Super. Cool. Is it a bit more clear now? I know it looks like a lot of different things, but now you know you can try to change the names and see how things works. Okay? I think we have a bonus. We can do quickly the bonus if you guys want, because it's always nice to plot things. But if you don't have time, just tell me, let me know. But we can try to run a plot. Or I can run it here and then you can run it when later on. Yeah? Nice. Okay, we do the bonus part and then we're done. Okay, this, we know already what is this, right? So we want to filter from Gapminder. We want to take only the year 2007. So let's do that. We run this and we have this new dataset called Gapminder 2007. Easy peasy, this we know. We saw this. Now we want to visualize it. So if we run this code here, the plot pane will open, and then you see this GPT per capita versus life expectancy. So let's disentangle this code, okay? Together. So ggplot works that it wants a specific, very specific syntax. What he wants to know first the data set. And we can tell him we want Gapminder 2007. Then S stands for aesthetic. So he wants to know what should he put in the x-axis? So here. Super nice. Super nice. So X stands for x-axis. So this is the GBT per capita, right? And then we want to know what do I put in the y-axis. We put life expectancy. And then we color by continent, for example. And that's what you see here. You see that all the different colors are different continents, okay? This you can play with. So, for example, the size of the dots, let's try to put 10. Alpha is the transparency. Let's try to put 0.1. Let's see how does it change. So 0.1, it's too much transparency. We don't like that. And maybe the size is a bit too big, right? So we can change it in 5 and 0.9. Yeah, better. I like it more. You guys can change the size as you like it or the transparency as you like it. And then we put it in the log scale because the GPT per capita otherwise is too big. So, for example, if we remove this line, let's see the difference. Yeah, it will look a bit like this exponential curve. How is it? No, logistic. I'm super bad at math. But yeah, let's put it in like a clear linear relationship, okay? And this, you don't really need it. For example, if I remove it, nothing much will happen. It's just that you don't have the title. So this says the title, call it like this. The x-axis, instead of call it like the column name, just say a better label, like GDP per capita. And Y, instead of the column name, call it life expectancy. And instead of continent with a minor c, the small c, like the column name, we want continent with the big C. Yeah, that's all it does. Okay? But let's try now with a box plot. So, ggplot, if you don't tell him anything, if you don't specify anything, it just makes points. That's his default. But we can also choose to tell him, instead of geometry, the points, I want a box plot. So this is, as you will see, this is exactly the same, except fill instead of color. But that's a box plot thing. We need to fill the color inside the box plot instead of just having the color. But then everything else is the same. So what if we run this? Yeah, we see the different box plot. So it will group the continents by box plot, and it will put them like this. So visually you can see, okay, Africa is average, the least, life expectancy, Oceania is the highest, and then the others are more or less in the middle. Okay? Okay, all good? So the last plot is a bit more complicated, but if you have a minute, we can walk through it together. And then, yeah, the scale, so it changes the value in the logarithmic scale. So if you see, so without this scale, the values go up to 50,000. But we divide that so that we have the values like are more restricted in the x-axis. So as you can see now, it goes only up to 30,000. Okay? It's just a matter of visualization. Sometimes you will have some very wide range of numbers that you prefer to see differently, but like for the sake of today, it's not really necessary. But in this case, I just wanted to see a nice linear relationship. But yeah, and this means that you scale the x values by log of 10, okay? But you can also do it for the epsilon, so the y value, okay? In this case, doesn't really make sense because if we try to do it, we can try. We try to do it and like for the year, yeah, doesn't really make much sense. But for the GDP per capita makes more sense. Yeah. But yeah, this is more a visualization trick, but it's not really necessary. Yeah. Log 10 is standard, yes, most of the time is standard. 5 minuti. Sì. Super. Let's do the last plot. So in this case, I combine the two things. So I want to modify my data set, and then I want to plot specific things, okay? We did this before. Like here we filtered the year 2007 and just we plot 2007, right? Now we do the same thing. We want to see, for example, the average life expectancy over time by continent. We did this before. We take the Gapminder dataset, we group by not only continent this time, or like before we did also country, but also year. Year and continent together. We group by these two different variables. And then we summarize, same as before. We've seen this, right? Where is it? Here, summarize. This is exactly the same. So if we run this life expectancy trend, what do we see? It will give you a warning. That's not a problem, okay? This is just telling you, yeah, I did it by year. Yeah, super. So you see that before we had only one group by continent and we had only one column here. In this case, we have two because we told him to summarize by, to group by year and continent. So we have both. Okay, then we want to plot this. So we take this dataset we just created. We want in the x-axis the year, in the x-axis the mean life expectancy, which is this new column we made, and again colored by continent. Instead of a point, we want a line because we want to see the trend over time, right? Over the year. And these are the labels I want in this plot. So let's try it. Oops. What will we see? We see that actually from the 50s to the 2007, life expectancy, the mean of life expectancy has increased in every country, in every continent. Okay? So this is something that maybe from the dataset we wouldn't have been clear to see. Yeah, this is not a big deal, sorry. Aesthetic line. Yeah, this I always forget. Yeah, this is just telling me that ggplot2, the new version, doesn't want size anymore, it wants line width. I keep forgetting, but yeah. Doesn't matter. This is just a warning, it worked anyway. So yeah, this is a good way to visualize your data after having summarized it, and you have this brand new data sets to work with, and you can plot some things. Okay? So I think this is the last exercise of my